This is the fourth session of Basic Thermodynamics. In this section, we will discuss about different types of thermometers. As we have discussed in previous section that the concept of temperature comes from zeroth law of thermodynamics. So, temperature measurement is necessary, and we know that we are quite familiar that the temperature is measured with the help of thermometers. Therefore, in this section, we will discuss different types of thermometer. First thermometer, it is called thermocouples. Thermocouple, it is one type of thermometer. It is basically works on the basic principle of Seebeck effect. According to this effect, when two dissimilar material wires are joined, then it forms two different junctions, and if these two junctions are maintained at different temperature, then EMF is generated. This experiment is called as Seebeck effect. The vice versa of experiment is also carried out. That means if any battery is connected in between junctions, then at both junctions different temperatures are formed. That means if any battery is connected in the circuit, at one end the higher temperature will be generated, and at another end lower temperature is formed. So this is very interesting experiment which has been explained, which has been shown in the slide. Look at the slide. These are the two different wires which is made of two different materials, and these two junctions are maintained at two different temperatures. In this diagram, in the first junction is maintained at 0 degrees centigrade and another junction is maintained at 100 degrees centigrade. What we are finding here, as these both junctions are maintained at different temperature, and EMF is generated. This is EMF. Okay. This experiment is known as Seebeck effect. Okay. And the vice versa is if battery is connected in between. Okay. Then at the same time, if battery is connected, then at two different ends, different temperatures are formed. Okay. So this is a very interesting experiment which is carried out by yourself, and this thermocouple is basically used in water cooler. In water cooler, the thermocouples are connected in series, and these thermocouples are joined. Thermocouples are connected to high voltage lines, and as it is connected at one end, the lower temperature is connected. Lower temperature is formed, and this lower temperature, when this side comes in contact with water, this water cools. This is the real life example of these thermocouples. So this is very interesting example of thermocouples. So what are the important points here? That in thermocouple, the thermometric property is EMF. We have already discussed what is thermometric property in previous section. The thermometric properties are the variables which are used in measurement of temperature. That means we have already discussed that temperature is function of pressure and volume as per guiding equation of PV is equal to mRT. If M and R are constant, in that condition what we have observed that this temperature is function of pressure and volume. Therefore, in that condition, pressure and volumes are the variables which are used in measurement of temperature. So in that condition, this pressure and volume are thermometric properties. Here for the thermocouple, the temperature measurement is depend upon this EMF. If the battery having different EMF is generated, at both junction different temperature is formed. So this temperature is measurement, it depends upon this E and F. So in that condition, for thermocouple, it can be said that this EMF is thermometric property. So for thermocouple, it is very important and interesting observation that you need to remember and you need to understand very clear that for thermocouple, the EMF is thermometric property. Okay, so this is the what about the thermocouples. Now we'll come on different types of next type of thermometer. Okay, next type of thermometer is thermistor. Okay, thermistor. In thermistor, just it is very important. This very important observation that in for thermistor, the resistance is thermometric property. You need to remember this one because these questions are asked several times in so many examinations. That what is the thermometric property for thermistor? In thermistor, just we need to understand that the resistance is thermometric properties. Okay. Next type of thermometer is constant volume gas thermometer. This figure I have shown here. This is constant volume gas thermometer. As we have discussed, this is the basic layout of constant volume gas thermometer. As its name that, just first of all look careful what is the name of the thermometer. Its name is constant volume gas thermometer. Constant volume, as we have already discussed in previous section, the temperature is function of pressure and volume. That means if for fixed M and R, temperature is function of pressure and volume. And in this thermometer, since this is constant volume gas thermometer, that means volume becomes constant. So if the volume becomes constant, in that condition temperature is function of pressure only. So this temperature measurement only depends upon pressure. So it can be said that for constant volume gas thermometer, pressure is thermometric property. Okay, so this is very important. In constant volume gas thermometer, the volume of gas get constant, therefore pressure becomes the thermometric property. This is very important observation. And because of its simplicity, the thermometer is predominantly used. Okay, so this is very important. So this is the next types of thermometer, constant volume gas thermometer. Next type of thermometer is constant pressure gas thermometer. This constant pressure gas thermometer, it is already clear that this pressure is constant, therefore in that case this volume will be thermometric property. So for constant pressure gas thermometer, volume will be thermometric property. So this is important. So these are different types of thermometer we have studied. Okay. So overall in this section what we have studied, now we are concluding the different facts and statements in zeroth law. So first thing that just I am giving some statements one by one. You need to remember this one. This is very important as per examination point of view and as per your knowledge point of view. So first of all, you need to have clear concept about whatever you are studying. You should have clear concept. You should have concept over that one, so that different types of problem you can solve. So you need to strike. You need to be focused on the basics, guidelines, basic concepts of particular topic. You need to connect. Okay. So I am giving one by one this important highlights of this lesson. So first point is from zeroth law of thermodynamics, that concept of temperature comes from zeroth law of thermodynamics. This is first point. Okay. Next important point is in the statement of zeroth law of thermodynamics. As we have discussed, if body A and body B are in thermal equilibrium and body B and body C are in thermal equilibrium separately, In that condition, body A and body C will also be in thermal equilibrium. Okay. Next point number 3, thermometric property. These are the variables which are used in measurement of temperature. This is the third point. Next point, different types of thermometer. Different types of thermometer. In first thermometer, we have studied this thermocouple. Thermocouple, it is the one types of thermometer, okay, which works on the principle of Seebeck effect. According to this Seebeck experiment, when two dissimilar materials are joined, then the two junctions are formed. When these two junctions are maintained at different temperature, then in that condition E and F is generated. So for thermocouple, the thermometric property is E and F. Okay, this is an important point you need to remember. Next point. Next thermometer is constant volume gas thermometer. Since it is said that constant volume, in that condition volume of this thermometer is constant, therefore we know that temperature is only function of pressure. That means measurement of temperature only depends upon pressure. So in that condition pressure will be thermometric property. So the constant volume gas thermometer, the pressure will be thermometric property. Next point. Next thermometer is constant pressure gas thermometer. Since it is called constant pressure gas thermometer, and we know that temperature is function of pressure and volume, and in that condition this pressure of this gas constant, so this temperature only depends upon volume of the gas. So in this condition the volume will be thermometric property. So this is the next point. That means for constant pressure gas thermometer, volume will be thermometric property. And last point, the next of important thermometer is thermistor. Thermistor, in thermistor resistance will be thermometric property. So this is all of the important points you need to remember by proper logic. Okay, thank you. We will meet in next session.